You know, we talk a lot about manufacturing here on Quality Digest. Manufacturers are a big part of our audience. And of course, when you talk about manufacturing, you talk about jobs. And when you talk about jobs, you eventually at some point talk about robotics.
Automation,
and when you talk about robotics, you usually end up saying something like, sure, they're great for repetitive tasks, but my job is secure. I mean, my job is so complex, a robot couldn't possibly take it over. I mean, look at my job, right? I sit at a desk and drink coffee all day. I mean,
that's hard.
Because it would make them rusty if they were to
the
do my job.
thing is, your head moves sometimes too, so you've got to have a line to your head. You
got to be coordinated.
That's right.
Well, the idea that your job is so complex, a robot could never do it, that is kind of true for most humans right now, but as you can see in the article, helping robots be less robotic, that reality is becoming less and less true as time passes. And you can kind of blame NIST for that in part. NIST and industry in general understand that in order for robots to be useful to small manufacturers and to allow larger manufacturers to offer more automated customization, and that's a key word there, customization, of high volume products, robots need to be more agile. I mean, and think about cars and cell phones where there's more and more of a push for mass customization. Robots would be ideal for that if they could change gears really quick, but currently robots are they're too cumbersome to retask, both physically and programmatically. So NIST is addressing this challenge head on with its Agility Performance of Robotic Systems project. The project's goal is to help manufacturing robot systems be more agile and to develop the measurement science that will allow manufacturers to assess and ensure the agility of their robotic system. Now, some of the key areas that NIST is looking at include, one, the ability of a robot to be rapidly retasked without the need to shut down. I mean, currently, that's usually not the case. You don't just have a robot doing a task and then just say, okay, well, go over there and do something different. It's got to be physically moved in many cases. It's got to be reprogrammed, retrained, and so forth. So it's not rapidly retasked. Number two, the ability of a robot to recover from errors. That's something that robots don't do very well. So for example, if a part is dropped, can the robot assess the situation and determine the best way to recover from that and to proceed? Which is really, if you think about it, a very human-like attribute. I mean, we recover very quickly. We understand what's happened and how to respond. And finally, thirdly, manufacturers also want the ability to quickly swap robots from different manufacturers, swap in and out, so that a company isn't tied to a single robot brand. Now, of course, nothing gets innovation going like good old-fashioned competition, so NIST is developing a set of performance metrics to measure robot agility, which they are going to validate at the upcoming Agile Robotics for Industrial Automation competition, ARIAC, in 2017. It's co-sponsored by ABB, Siemens, and Dassault Systèmes. ARIAC will let teams test their robot control systems on a simulated manufacturing factory floor where the sponsors are going to throw agility challenges at them to see how well they respond. So if you're interested in that competition, there is a link to NIST's ARIAC webpage toward the end of the article that's listed down below, the player page down there. So basically, how can we make robots smarter so that they can do more jobs that humans do, so we can put more humans out of work?
Well, but here's the thing. This whole idea of robots becoming more and more humanistic as we move forward, I think we're going to find as we go forward that it's a lot more difficult. I mean, the human brain doesn't really work mechanistically.
Well,
think about it.
We've talked about this before.
Well, yeah, but I think that there's something to that. There's a soul there. The idea that when something drops, you can figure out in real time what's going on, what happened, and what you have to do with it. I don't know. Maybe it's just me. I'm not a scientist, but to me, that seems like there's a germ of something there that you just can't program.
Well, if we get to the point where you can't tell the difference between me sitting here and the robotic me sitting here, then we'll have passed the Turing test. And
I can't tell now.
What can I say?
I did. Anyway, that stuff is always fascinating to me. Though. I tell you, it's great stuff. Right. We'll keep our eye on it going forward. All right. you.